Hi, I am Arib. You are watching my YouTube channel. Working principle of overcurrent relay. Definition: in an overcurrent relay, there would be essentially a current coil. When normal current flows through this coil, the magnetic effect generated by the coil is not sufficient to move the moving element of the relay, as in this condition the restraining force is greater than deflecting force. But when the current through the coil increases, the magnetic effect increases, and after a certain level of current, the deflecting force generated by the magnetic effect of the coil crosses the restraining force. As a result, the moving element starts moving to change the contact position in the relay. Although there are different types of overcurrent relays, but basic working principle of overcurrent relay is more or less same for all. Working principle of overcurrent relay: the core component of an overcurrent relay is a current coil. Under normal conditions, the coil's magnetic effect is too weak to overcome the restraining force and move the relay's element. However, if the current increases sufficiently, its magnetic effect intensifies, surpassing the restraining force and prompting the moving element to alter the relay's contact position. This fundamental working principle applies across different types of overcurrent relays. Types of overcurrent relay. Depending upon time of operation, there are various types of overcurrent relays, such as instantaneous overcurrent relay, definite time overcurrent relay, inverse time overcurrent relay. Inverse time overcurrent relay, or simply inverse OC relay, is again subdivided as inverse definite minimum time (IDMT), very inverse time, extremely inverse time overcurrent relay, or OC relay. Instantaneous overcurrent relay. Construction and working principle of instantaneous overcurrent relay is quite simple. In an instantaneous overcurrent relay, a magnetic core is wrapped with a current coil. An iron piece, supported by a hinge and a restraining spring, is positioned such that it remains detached from the core when current is below a preset threshold, keeping the normally open, no contacts open. Exceeding this threshold, the increased magnetic attraction pulls the iron to the core, closing the contacts. We refer the preset value of current in the relay coil as pickup setting current. This relay is referred as instantaneous overcurrent relay, as ideally, the relay operates as soon as the current in the coil gets higher than pickup setting current. There is no intentional time delay applied. But there is always an inherent time delay which we cannot avoid practically. In practice, the operating time of an instantaneous relay is of the order of a few milliseconds. Definite time overcurrent relay. Ideal inverse time characteristics cannot be achieved in an overcurrent relay. As the current in the system increases, the secondary current of the current transformer is increased proportionally. The secondary current enters the relay current coil. But when the CT becomes saturated, there would not be a further proportional increase of CT secondary current with increased system current. From this phenomenon, it is clear that from trick value to certain range of faulty level, an inverse time relay shows specific inverse characteristic. This relay is created by applying intentional time delay after crossing pickup the value of the current. A definite time overcurrent relay can be adjusted to issue a trip output at an exact amount of time after it picks up. Thus, it has a time setting adjustment and pickup adjustment. Inverse time overcurrent relay. Inverse time overcurrent relays, typically found in induction type rotating devices, operate faster with increased input current, inversely varying their operation time with current. This characteristic is ideal for swift fault clearing in severe conditions. Additionally, this inverse timing can also be programmed into microprocessor-based relays, enhancing their versatility in overcurrent protection. Inverse definite minimum time over current relay or IDMT-OC relay, ideal inverse time characteristics cannot be achieved in an overcurrent relay. As the current in the system increases, the secondary current of the current transformer is increased proportionally. The secondary current enters the relay current coil. But when the CT becomes saturated, there would not be a further proportional increase of CT secondary current with increased system current. From this phenomenon, it is clear that from trick value to certain range of faulty level, an inverse time relay shows specific inverse characteristic. But after this level of fault, the CT becomes saturated and relay current does not increase further with increasing faulty level of the system. As the relay current does not increase further, there would not be any further reduction in time of operation in the relay. We define this time as the minimum time of operation. Hence, the characteristic inverse in the initial part, which tends to a definite minimum operation time as the current becomes very high. That is why the relay is referred as inverse definite minimum time over current relay or simply IDMT relay.